Good morning, students. Can you hear me? Can everyone hear me? Can
Yes, sir.
everyone hear me? Yes?
Yes.
Okay. So let us start. Okay. In the last class, we basically discussed regarding stress and
Yes.
strain. Right. We basically discussed regarding stress and strain. Yes or no? So do you remember those things?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now what was stress? Stress was defined by what? Force acting per unit area. Yes or no? And strain means what? Changing
Yes.
length by original length, right? So change in length by original length and force applied per unit area. So these are the two basic principles. Hmm. Now there is another term called Hooke's law. Okay. So what is Hooke's law actually? This one. Just remember that if stress is directly proportional to strain, then this is called Hooke's law. Is it clear? Is it clear? Are you able to see it, students?
Yes, sir.
Okay. So if stress is directly proportional to strain, then this is called Hooke's law. Okay. Now we'll go to the different types of strain. Ah, for different types of strain, for different types of strain, it is called longitudinal strain. Can you hear me? Hello, hello.
Sir, we can hear you. You can continue, sir.
You can hear
We
me,
are
huh?
hearing you, sir.
Okay.
Yes, sir.
So longitudinal strain and hello. There are different types of strain. So first of all, what we'll discuss is longitudinal strain. Okay. So what is longitudinal strain? When a body is subjected to an axial tensile or compressive load, when a body is subjected to an axial tensile or compressive load, there is an axial deformation in the length of the body. The ratio of axial deformation to the original length of the body is known as longitudinal strain. Got it? Now, if you try to understand it, I'm telling you now. The body is subjected to an tensile or compressive load. You have understood now beforehand what was tensile and what was compressive. Suppose this is a body. Suppose this is a body. Okay. So what happens if the load is like this? Then it is what? Can anyone say me? Then it is
Shift.
what? Can anyone say me what kind of load this is? Huh?
Compressive load.
Very good. This is
Compressive
compressive.
load.
Yeah, I understood. I'm sorry. Very good, very good. So this is compressive. And if it is in this direction, then it is called what?
Tensile.
Yeah, good. So,
Tensile.
yeah, I heard it. Very good, very good. Yeah, good. So, what happens? Once load is applied to a body, then there will be what? There will be some deformation in the length of the body, right? Then there will be deformation in the length of the body. So the ratio of axial deformation to the original length of the body is known as longitudinal or linear strain. Okay, just remember that the ratio of axial deformation to the original length of the body is known as longitudinal linear strain. Now, do you know what is axial deformation? Can anyone say me? Can anyone say me what is axial deformation?
I think it should
Along
be
the
a
direction of
linear.
force.
Yeah, and
Along the
anyone else?
direction of force.
Along the direction of force.
Along the
Yeah.
direction of force.
Anyone else? Yeah, and anyone else? Can anyone else say me? What do you mean by axial deformation? No idea? Look, some people have said it along the direction of force or along where the force is applied. So like this, suppose this is the axis where force is applied. Huh? Okay, I'm drawing in a more. So here is the force are applied like this. That means what? This is coming in a particular line, right? This is coming in a particular line, right? So if this is in a particular line, that means what? Suppose be it compressive, this is compressive, or be it tensile, then also what will happen? This will get compressed in this direction only, no? In this direction and in this direction only. So it will be compressing in one direction. That means along this axis only, right? So therefore, it is known as what? Axial deformation. Okay. So now in the last class, I showed you one picture of del L. How it is del L? Do you remember that? Do you people remember that?
Yes, ma'am.
Huh? So this is the one. So how del L is happening? Are you able to see it? Are you able to see it?
Blank.
No?
It's blank, sir.
It's blank. I think so it should come. Just a minute.
Yes.
Is it coming? Is it coming?
No.
No.
What about others? Temazar?
Not even.
Nothing is coming?
No. No. It's blank.
Huh?
White. Blank.
Blank.
Bulang.
Blank, na? Wait, wait.
Yes.
Just give me a minute.
Yes.
Give me a minute. Then. Is it coming now? Is it coming?
Yes, sir.
Okay. That means what? This del L, change in length by original length, del. That means what? This is known as the axial deformation or longitudinal strain. Okay. Now we'll see about the next one. You got it? What is longitudinal strain? Now we'll go for lateral strain and shear strain. Now look, if you see this figure, if you see this figure here, This figure shows everything actually. The force is applied here. Can you see it? Can you see this one PDF? Can you see this presentation, students?
Yes.
Yeah. So this is what? So this is the force that is applied, and because of this force, there is one deformation. Look. Now the whole thing is L plus del L, and this is del L. Similarly, what happens? Look, this is D. This is D, right? So what happens? If this is D, then del D by D. Suppose the force is applied here, and the strain occurs in the direction perpendicular to the applied stress. So that means what? You are applying the force, but this thing, this is the perpendicular direction, no?
Sir,
Yeah.
hello,
Say.
sir.
Yes, say. Please carry on. Any problem? Hello? Hello? Are you having any problem? You're not understanding? Who's who was speaking right now? Yeah. Are you having any problem? Excuse me.
Sir, it's okay, sir. You can continue, sir.
Yeah, I can continue. Yeah. Okay. Please write in the chat, okay, if you're having some problems, okay? Rather than just something in the middle. So now what happens? Look, this is what? This is D. D means what? The diameter, right? The force is applied here. If you see here, the force is applied here, and eventually what happens? The D changes. Initially, this was the D, huh? And after that, what happens? It changes by an amount of delta D, right? If it changes by an amount of delta D, then what happens? Then what happens if it changes by an amount delta D? Then this is what? Lateral, right? Can you differentiate between longitudinal and lateral thing? If not, you can ask me again. Okay? So if you see here, this force is applied here. Because of this force, there is a change in the diameter. And that means what? There is a change in this. Del D is the what? Change. Change in length. And D is what? The original length. That means what? We will be able to define lateral strain like this. The strain which occurs in the direction perpendicular. Why? Because the force is applied here and the strain is occurring here, right? The strain is occurring like this. That means what? Del D by D. Yes or no? This is lateral strain. Is it clear, everyone? Or any doubt? Yes, students, is it clear, everyone? Students, is it clear, everyone?
Sir.
Huh? Is it clear?
Yes,
Come
sir.
on. Come on, it is clear?
Yes,
Yes, sir.
sir.
And what about other? Yeah, tell me that yes. Okay, good. Very good. So now we'll go to what? The next one. This is a very important topic. This is a very important part. I'm telling you. This is shear strain. Okay. What is shear strain? So shear. From the shear is means what? The shearing strain is defined as the ratio of deformation of the distance between two parallel surfaces on which the deformation takes place. Now, if you see, we got lateral strain and longitudinal strain. right? Now for shear, what means what? Suppose suppose the body is moving in this manner. Can you see the figure? Can you see the figure?
Yes.
Huh? Can you see the figure?
Yes, sir.
So the
Yes.
body is moving in this manner. Okay? So if it is, look, one force is applied in this direction, the other force is applied in this direction. I'm giving you a practical example. Okay? If you take a book which is having a very large number of pages, and eventually what will happen? You put your hand on the top and bottom, and you just try to what? Move it in this direction. Then there will be one deformation taking place. Can you recall that thing? Have you done that thing? Yeah, students, can you recall that thing? There is some deformation
One
that is. Huh? Hello, 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 hello.
second. Once more.
Once more you need. So if you take a big book, if you take a big book and what? You try to move your hand in that direction. Then what happens? There is one deformation that is taking place, right? Wait, I'll show you. Wait. Okay. Can you see my video? Can you see my video? Students, can you see my video?
Yes.
Okay. So now
Yes.
if you have a look at it, wait. Now I'm taking this book. Look at this book. Okay. So now what happens? Now this is like this, right? Now if I give some deformation, if I try to move this from here and the one from the other side, what happens? There is certain amount of angle is here, right? If you see, there is certain amount of angle here. So eventually what will happen? The top is remaining at one part and the bottom is remaining at some other part. Yes or no? Like in the figure. Now you are applying force from one from his side, the other from that side. That means what? This is inclined and this is moving a little bit. Can you get me? Can you get me now? Can you get me now, students? Can you get me?
Yes, sir.
So this is known as Temazar, you understood, no?
Sir.
Okay, good,
Sir.
good. Okay, you are getting them. Kabom and all. Yeah, very good. This is known as what? This is known as shear stress. Okay. So now, are you having copies with you? Students, are you having copies with you?
Sir.
Yes? Are you having your
Yes,
copies
sir.
with you? Yeah, hello.
Yes.
Yes.
Okay. So let us try out a numerical now, because this is a numerical based subject, no? Therefore, everyone has to do the numerical. Wait, I'm giving you a numerical now. calculate the strain in a, right, calculate the strain in a 15-meter long structural member which is,
Sir, can you repeat?
calculate the strain in a, calculate the strain in a 16-meter long structural member.
16.
Yeah,
Calculate the strain in a.
wait, I'm writing the question for you people. Just give me a minute. Is it okay?
Okay, sir. Okay.
Yes, sir.
Are you able to see the question?
Yes, sir.
Yes.
So you have to find out what. This is very simple. The most simplest numerical that you can see.
Strain.
Yeah, good. So strain in a 16-meter long structural member and it elongates 1.5 centimeter when subjected to a load this one. So you have to find out the strain. Okay. So I'll give you, it is 11:41 now. I'll give you 2 minutes to solve it. Just who can say the answer, you have to say me. Have you noted down the question, everyone? Have you noted down the question?
Yes, sir.
Okay.
Sir.
Yeah. So now try to find out the answer.
Sir,
Yeah.
sir, I got a solution, but it may be wrong, sir. Don't know.
Why you are wrong? This is a so easy numeral. You have to be
Uh,
confident and give me the answer. I can't.
Sir, 9.3.
What about others?
11.
Yeah. What about others?
11 meters, sir.
11
Oh,
meter.
11, sir, not meter. 11. 11, 11.
11 meters, sir.
Is it? Is it? Huh?
My side, sir. It may be wrong, but from my side.
Why your side?
You correct it, sir.
I'll have to correct it now. Try it out, try it out, try it out again. Yeah. So
9.3 into 20 power 3.
9.3 into, someone said, tell me the answer.
9.3 into 10 to the power minus 3.
9.3 into 10 to the minus 3.
Yeah.
Is it? Is it? Ha! You are making very silly mistakes, everyone. Wait, I'll show you the answer. Look at this. Is it? Will it be like this now? Yes or no?
Yes.
Yeah.
Fine, it's fine, sir.
Yes.
What?
According to your
You
dictation,
put
I
the wrong
write
answer.
16 mm.
You got wrong
16 m.
answer. You got wrong answer, Team Azad. So this is the correct one. Yes or no? I have changed the units. If you can see, this is centimeter. Yes or no? This is centimeter and this is meter. This is centimeter and this is meter. So we have to make these two in terms of one unit, no? Then only we'll get the answer. Yes or no? Yes or no?
Yes.
Yeah?
Sir.
Yes, sir.
So it will be what? The answer is
9.3
it will be
10 to the minus 4.
10
9 point
10.375.
no what 10.37
37.
9.375 into 10 to the power
Minus 4.
hmm, 10 to the power what? Minus
Minus
4.
4.
Yeah. So this is the answer. Simple. Now is it clear? Now is it clear?
Yes, sir.
Okay.
Yes, sir.
Remember one thing. The units are very important. If you are not clear with the units, then yeah, Trubhajyoti, you got the answer. Good. Trubhajyoti does only answer the it correctly. Very good. You should speak up, right? You should speak up. Yeah, Trubhajyoti got the answer correct. So this is the answer. Is it clear, everyone? Now the basic thing of stress and strain. Is it clear?
Yes.
Okay. So now,
Sir,
yeah, please carry on. Say, you have any problem? You didn't understand? Hello? Hello? Hello?
sir.
Yeah.
Sir.
No, sir.
What? You didn't understand?
No, sir.
Just write in the chat. Please write in the chat. Your audio is not clear. A lot of noise is coming. Just write in the chat about your question. I'll try to solve it out.
No, sir. Can you please experiment against that
Which one? Which one? Which one? Please write in the chat. Please write in chat. Which one I need to explain? I could not hear you. I could not hear you. Can you please repeat again? Or shall I go to the next part? She. Hey, mother, do you know who was she asking? What was she asking?
Manner
Okay.
from Meghalaya student. I think she asking about a numerical.
Yeah, which one? Which one? That's what I didn't understand.
Last one. We have did strain.
Oh, that one. Okay, okay. I'll just explain it
Sir,
again. Yeah,
she was
say.
asking to give an example of that numerical, sir.
Example of the numerical. How will you get an example
Yes,
of the
sir.
numerical? This is a
Can,
numerical, right? So how will you get an example of the numerical?
I don't know.
Huh?
I don't know
It's a
that. She was saying,
calculation, sir. I think
Look,
expand it
I'll draw.
calculation. How
I'll
you put that? How
wait.
you put that?
Wait.
Units. I think they get confused in that portions. C got confused
Wait.
in
Wait.
that
Wait.
portions.
Give me a minute. Now, what I will do is, this is the diagram. I'll try to explain you. So, the diagram will be somewhat. How it will look. This is one. This one, no. So after that, just the force is applied here, and the force is applied here. Because of this application of force, there is what? Change in length, right? If there is change in length, then what will happen? Then basically this is elongating. So that means what? This is a tension force. If this is elongating, then it elongates by 1.5 centimeter. The original length is 16 meter. So as simple as that, del L by L. So this is how you are doing. This is centimeter, you are converting it to meter like this, and this is meter. As simple as that. Okay. So I think so she understood. So let us do one thing now. Let us go to the next. Just now we discussed about Hooke's law. So what is Hooke's law actually? Hooke's law states that, can you see the screen now?
No, sir.
No.
Nothing.
Give me a minute. Yeah. So what is Hooke's law? Hooke's law states that stress is proportional to strain within elastic limit. This is the basic definition of Hooke's law. Okay. So now what is basically Hooke's law? Suppose if you see this graph, this here. So what is this graph? Suppose this is the graph, right? So if this is the graph here, so that means what? In this graph, you can see that the stress and strain, they both are what? They both are proportional to each other. That means what? This is the basic principle of Hooke's law. Stress is proportional to strain within proportional limit or within elastic limit. So mathematically, stress is represented by what? Sigma, and strain by this epsilon. So that means what? Sigma is proportional to epsilon. Now, if it is proportional, then there will be one constant to make this equal. Yes or no? So, if there is one constant present, then this constant is called constant of. I'm not asking for your attendance, Santijulu. Constant of proportionality. So, this is known as the constant of proportionality. So, what happens is that this constant of proportionality is there, then that means what? Stress is directly proportional to strain within elastic limit. Now this constant is known as Young's modulus or modulus of elasticity. This is a very important term, I'm telling you. This is known as Young's modulus or modulus of elasticity. So that means what? This was determined by Thomas Young. So this was experimentally done by Thomas Young. And the constant of proportionality, that means Young's modulus. Young's modulus is what? Young's modulus is actually a property of the material. So it depends upon the various materials. That means what? It varies according to the materials. Suppose the Young's modulus of steel will be different to that of iron. The Young's modulus of plastic is different. That means what? For different materials, the Young's modulus will be different. So this constant of proportionality, this constant of proportionality was determined by a scientist called Thomas Young. So this is known as Young's modulus. That means what? Hooke's law can be stated that stress is directly proportional to strain. Now let us try to understand this. Okay, we all know stress sigma. Stress is denoted by sigma, right? Stress is equal to what? Can anyone say me what is stress? What is stress?
Change in length by original length.
This is strain. This is not stress.
Oh, stress.
Wrong.
Sorry.
You have to be what? Well, I'm asking about stress, not strain.
Force per unit area.
Good. Very good. Stress is force.
Force per unit area.
Stress is force by area. Right. If stress is force per unit area and strain. Strain is denoted how? Strain is denoted by epsilon. So strain is what? Force per unit area we can write like this now. We know F equal to P. That means denoting force, we can either denote it by F or P. So this is what? P by A. Okay, so this is force per unit area. And strain. Strain means what? Del L. Del L means what? Change in length. Temazar, now you understood? Temazar?
Due to audio system, sir.
Huh? Huh? क्या हुआ? क्या बोला? I didn't understand you what you were saying.
नहीं सर,
Cannot.
कंटिन्यू, कुछ नहीं, ठीक है, थोड़ा सुनने में गलती हो गया था.
हाँ. So this is what del L by L. So stress and strain. Stress and strain is this two, right? That means what? According to Hooke's law, stress is proportional to strain. So you can write like this: P by A equal to E into del L by L, and eventually what we can write like this: PL by AE. This is what is the basic thing. Okay. So what we'll do is